Hello students, welcome back to Engineers Academy. Do subscribe my channel if you haven't done it yet. Now we are going to solve this problem which says that determine the components of reaction at the fixed support A. The 400 Newton, 500 Newton and 600 Newton forces are parallel to the X, Y and Z axes respectively. So we have these three forces. This 400 Newton is parallel to the X-axis, this is parallel to the Y-axis and this is parallel to the Z-axis. And here we have the fixed support. So at fixed support, the fixed support can always provide the force reaction in all the direction, and it can provide the couple reaction in all about all the axes. So let me represent all those reactions. So let's say that at A, in the X direction, let's say that we have AX support reaction, then we will have AY, and let's say that in the positive Z we have AZ, and then we will have the couple reaction, right? So at about the X-axis we have this couple reaction. This is we can say that this is MAX. Similarly, about the Y-axis we will have the couple moment like this. This is MAY, and about the Z we have this MAZ. And if we curl our right hand fingers in this direction, so the thumb will point out in the positive X. So this means that if we look into this couple moment from this direction, so it is counterclockwise moment about the X-axis, so that is why we have the thumb in the positive X direction. So we have assumed that all the moments are counterclockwise moments. So now, first of all, since this whole mechanism is in equilibrium, so we can apply the equilibrium condition, and the first condition that we can apply is the summation of forces along the X-axis. So that must be equals to 0. So the summation of forces along X, this must be equals to 0. So in the X direction, we have this 400 Newton force and we have this AX. So AX is in the positive X and 400 Newton is in the negative X. This one is along Y and this one is along Z. So the summation of forces along X, we get AX. AX is in the positive X and 400 Newton is in the negative X. This is equal to 0. So we can say that AX is equal to 400 Newtons. Similarly, if we apply the summation of forces along Y, that is equal to 0. So in the Y direction, we have AY, this AY. So we will write plus AY. And then we have this 500 Newton force in the positive Y as well. So this is plus 500 and this is equal to 0. So from this we get that AY is equal to minus 500 Newton. So the minus sign tells us that the assumed direction of AY is not accurate. AY is actually acting towards the A. So the negative sign tells us that the initial assumed direction need to be reversed. So AY magnitude is 500 Newton and it is acting towards that point A, that is in the negative Y direction. Similarly, if we apply the summation of forces along the Z axis, that must be equals to 0. And in the Z direction, we have this AZ. This is in the positive Z, so I will write plus AZ. And this component, this force, external force, is acting in the negative Z. This is 600 Newton, so we will write minus 600 and this is equal to 0, and from this we can say that AZ is equal to 600 Newtons. So now we have determined that force reactions AX, AY and AZ at point A. Now to find these couples MAX, MAY, MAZ, we will apply the summation of moment about the X-axis. That must be equals to 0. Now the summation of moment about the X-axis is equal to 0. So as we can see that this 400 Newton force, this is parallel to the X-axis. It's not going to produce the moment about the X-axis, since it can only try to translate this whole mechanism in the negative X direction. So it's not able to produce the moment about the X-axis. So this 500 Newton force, this can produce the moment about the X-axis in this direction. So, and this 600 Newton, this can produce the moment about the X-axis in this direction. So we have MAX, this MAX is in the positive X, this is the counterclockwise moment, so I will write plus MAX. and the moment produced by this 500 Newton force about the x-axis is 500 multiplied by the perpendicular distance between the 500 Newton force and that x-axis. So if we extend the line of action of this 500 Newton force, so the perpendicular distance of the x-axis from, or we can say that the perpendicular distance of this force from that x-axis is this distance, which is 0.75 plus 0.5. So 0.75 plus 0.5 is 1.25. So the moment arm of this 500 Newton force from that axis is 1.25. So we will write that 500 into 1.25, and this 500 Newton force is producing the moment about the x-axis in this direction. And if we curl our right hand fingers in this direction, so the thumb will point out in the negative x. So this is the direction of the moment produced by this 500 Newton force. If we curl our right hand fingers in this direction, so the thumb will point out in the negative x. So this means that it is producing the clockwise moment about the x-axis. Now this 600 Newton force is producing the clockwise moment about the x-axis, just like that 500 Newton force. So we will write minus, since if we curl our right hand fingers about the x-axis in this direction, so the thumb will point out in the negative x. So that is why it's producing the clockwise moment. We will write 600, and the perpendicular distance of this 600 Newton force from that x-axis is this 1 meter distance. So this is the moment arm of this 600 Newton force from the x-axis. So I will multiply this with the 1 meter distance. So this is the moment arm. This will be equal to 0. Now let me draw the free body diagram of this whole mechanism from this side. Let me draw the projection. So if we look into this whole mechanism from this side, so we will be able to see the YZ plane. So let's say that we have, this is my YZ plane, and this line represents the pipe, and this pipe has a height of, from the ground this height is 1.25, this 0.75 plus 0.5, so this height is 1.25. Then the pipe is bent towards the y-axis, so that is towards the y-axis, it is 1 meters. This is 1 meters, this 1 meters, and then the pipe bends towards the x-axis. So if we look into this whole mechanism from this side, so from this point the pipe goes into the screen, so that we cannot draw that, we cannot show this part of the pipe in our 2D diagram. So this is we can say that this is the YZ plane. This is the free body diagram in the YZ plane. So now the 400 Newton force is acting towards the x-axis. So since the x-axis is out of the screen, this is my y-axis, this is my z-axis, and the x-axis is out of the screen. Let me show that the x-axis is out of the screen. So how to show that? We will draw a circle and then we will draw a dot. So this is the x-axis which is out of the screen. So everything parallel to the x-axis will not be visible in this YZ projection. So we will be able to see AY reaction, and we will be able to see AZ reaction. And AX is out of the screen, so that is not visible. Similarly, this 400 Newton force, this is in the X, so it will not be visible in this particular projection. Similarly, we have the 500 Newton force at this particular point at a distance of 1 meter. This is 1 meter. So we will have that 500 Newton force. And this 600 Newton force is acting in the downward direction. So that will be visible, that will be acting at this particular point. So this is 600 Newton force. So now the x-axis is here, the x-axis is out of the screen. Now if we find the summation of moment about the x-axis, so as we can see that this 500 Newton force is producing the clockwise moment about the x-axis. So that is why we have minus 500, and the perpendicular distance of this 500 Newton force from that x-axis is this distance, which is 1.25. And similarly, this 600 Newton force is producing the clockwise moment about the x-axis, and its perpendicular distance from the x-axis is this 1 meter distance. So that is why we have this equation. So I hope this will help you people in understanding to write this particular equation. So now we can say that MAX is, we can write that MAX, that couple reaction at A about the x-axis is equal to 500 into 1.25 plus 600 into 1. So this gives us 500 into 1.25 plus 600. This gives me 1225 Newton meter. This is the couple moment reaction at A about the x-axis. Similarly, if we apply the summation of moment about the y-axis, that must be equals to 0. And for y-axis, let me draw the free body diagram of this whole mechanism from this side. So that will be our xz projection. So first let me draw the xz projection. So we will have the x-axis is like this, that is towards the left, and the z-axis is in the upward direction. This is my z-axis. Now we are observing this whole mechanism from this side. So towards the left is our x-axis, and in the upward direction is our z-axis. And along the z-axis we will be able to see this pipe. So this pipe is of height 1.25. This line represents that pipe. And then this portion of the pipe is towards the y-axis, and in this particular free body diagram, in this particular projection, the y-axis is out of the screen. So let's show that the y-axis is out of the screen. So now in this diagram, we cannot show that the pipe is out of the screen since it's a 2D diagram. So we will directly draw this part of the portion, and this part of the pipe is towards the negative axis. So we will draw it here. So this is 0.75. So we will have 0.75 like this. Now, since in this particular projection, the x and the z axis are visible, so the components or the forces along the x and z axis will be visible, and the y axis is out of the screen. So anything along the y axis will not be visible in this particular projection. So we will write that this is the x z projection. So now the 400 Newton force is acting. This 400 Newton force is acting at a distance of 0.75 from this ground. So we will have that 400 Newton force somewhere here, and this height is 0.75 meters. Similarly, since this 500 Newton force, this is along the y-axis, it will not be visible in this particular free body diagram, and this 600 Newton force is acting in the negative z, so it will be visible like somewhere here. This is that 600 Newton, and here the AX reaction will be visible and AZ reaction will be visible, and AY reaction is out of the screen, so that will not be visible. Now, considering this particular diagram, we are going to apply the summation of moment about the y-axis. Again, y-axis is out of the screen. So now, as we can see that this 400 Newton force is producing the clockwise moment, and this 600 Newton force is producing the clockwise moment. Now, this 600 Newton force is at a distance of 0.75 since we have drawn this free body diagram from this side. So now we can write that the summation of moment about y is equal to 0, and we can say that about the y-axis we have that couple reaction, which is MAY. So I will write plus MAY, and then this 400 Newton force is producing the clockwise moment, so we will write minus 400, and the perpendicular distance of this 400 Newton force from that y-axis is this distance, which is 0.75, and this 600 Newton force is producing the clockwise moment, so we will write minus, and the moment arm of this 600 Newton force is 0.75. This is the perpendicular distance of this 600 Newton force from that y-axis. So we will multiply this with 0.75. This is equal to 0, and we can say that MAY is equal to 400 into 0.75 plus 600 into 0.75. So this is 400 into 0.75 plus 600 into 0.75. This gives me 750. So MAY is equal to plus 750 Newton meter. Now again, if we directly find the summation of moment about the y-axis is using this particular diagram. So the summation of moment about y, for that, to find the summation of moment about y, first of all, this 500 Newton force, this is parallel to the y-axis, so it's not going to produce the moment about the y-axis. So this 500 Newton force is not visible in this particular diagram. So this is not going to produce the moment about the y-axis. This 400 Newton force is producing the moment about the y-axis in this direction. And if we curl our right hand fingers in this direction, so our thumb will point out in the negative x, in the negative y. So that is why that we are saying that this 400 Newton force is producing the clockwise moment about the y-axis if we observe the whole mechanism from this direction. So that is why we have minus sign here. Similarly, this 600 Newton force is producing the clockwise moment about the y-axis, and the perpendicular distance of this 600 Newton force from that y-axis is this distance. So that is why we have minus sign here, and the perpendicular distance is 0.75, and ultimately we get that couple moment at A about the y-axis is equals to 750 Newton meter. Similarly, we can apply the summation of moment about the z-axis. So now again, for z-axis, we can draw the free body diagram from the top, and then that will be easier for us to find the moment about the z-axis. So let's draw the free body diagram from the top. So from the top, we will be able to see the x and y plane. So now the x plane will be in the downward direction, the x-axis will be in the downward direction, the y-axis will be towards the right, let's say, and the z-axis is out of the screen. Now if we observe this whole mechanism from the top, this part of the pipe will not be visible since it is along the z-axis, and the z-axis is out of the screen. So we will be able to see this part of the pipe which is along the y-axis, and we will be able to see this part of the pipe which is along the negative y. This is in the negative x, this is positive x, this is in the negative x. So we will be able to see this portion of the pipe which is along the positive y, and it has a length of 1 meters. So this is that particular part of the pipe, this is 1 meters, and then we will be able to see this part of the pipe which is in the negative x. So we will be able to see this part of the pipe. And now in this particular diagram, we will be able to see all those forces which are along the x and y, since the z-axis is out of the screen. So now this 400 Newton force, this is in the negative x. So this 400 Newton force is parallel to the x-axis, so we will be able to see this 400 Newton force that will be acting somewhere here. This is 400 Newton. Similarly, this 500 Newton force, this is in the positive y, and that is going to act somewhere here. This is that 500 Newton, and this 600 Newton force, this is along the z-axis. So this is acting in the negative z. So it is going to act somewhere here, but it is towards the screen. So we cannot show that force. Now, if we apply the summation of moment about the z-axis, the summation of moment about the z-axis, that must be equals to 0, and here we will have that couple moment which is to be determined, that is MAZ. And similarly here we will be able to see that AX. Let me show that here we will be able to see that AX as well. And here we will be able to see that AY as well. But this AX, AY, and this 400 Newton force, they are intersecting with the Z-axis. They are intersecting with the Z-axis, so they are not going to produce the moment about the Z-axis. And this 500 Newton force, this is intersecting with the Z-axis. Its perpendicular distance or its moment arm from the Z-axis is 0, so it's not going to produce the moment about the Z-axis. So this means that there is no moment about the Z-axis. So we can say that the MAZ, in all of these three forces, no one is producing the moment about the Z-axis. Since this one is parallel to the Z-axis, this one is passing through Z-axis, and this one is also intersecting with the Z-axis. So none of these forces is producing the moment about the Z-axis. So this means that the couple moment reaction at A about the Z-axis is 0. So now we have determined that AX, AY, AZ, MAX, MAY, and MAZ is equal to 0. So this is the solution of this particular problem. I hope this will help you in your learning. Let me know in the comments if it helps in your learning. Do subscribe Engineers Academy. That will help to promote my channel.